Okay, everybody, it's time for the last session for today. And it's going to be a talk on how to build OSGi projects with BND and Maven by Ray Auge and Tim Ward. So please, take it away.
Hi, everybody. I hope you're having a good conference so far. Like Krister said, I'm Ray Auge, and I work for LifeRay. And Tim Ward, my colleague here at the OSGi Alliance. We've been working on expert groups for a number of years now. Tim's a board member. And yeah, hopefully we can show you some cool BND tooling stuff. Any words?
Yeah, just to say that obviously I've worked with Ray for a while on OSGi, but actually we're here with our BND hats on today. So we are both BND hackers. We commit, we go around and we do crazy stuff with Maven, because for a long time Maven and BND, they were not good friends. And we have spent a few years, but we think we finally reached the point where using BND with Maven is as good or better than using BND in any other way. So,
there we go.
I'm going to start by talking to you about the original bad boy, the BND Maven plugin. So this is the first Maven plugin that was actually produced by the BND team. It's not the first Maven plugin that used BND, but it is the first one we built ourselves. And it's basically the thing that lets you take BND and put it into the Maven lifecycle. It generates your bundle metadata, it generates your DS metadata, your metatype, all of the stuff that you know and love from getting BND to build your bundles. This is the plugin that does that. And you should be applying it to every single project, whether or not you think you might use it in OSGi. Because an OSGi bundle is just a jar file. All of your jar projects can be OSGi friendly by applying this plugin and it generating the metadata you need. And it typically lives in the process classes phase, and the reason for this is that's what BND does. It actually reads your class bytecode to get this stuff done. So it's really important, therefore, that you are aware you're not ever getting anything from the source. It's always the class binaries. Everything's being generated, and this is including stuff like JPMS info we can now generate based on your OSGi metadata. So that plugin's pretty cool.
The next plugin we have is the BND Indexer Maven plugin. And if you're at all familiar with BND over any length of time and building a big project out, usually you would try to put the metadata about your bundles that you're using into a repository. And so the BND Indexer Maven plugin is about building out these repositories from collections of artifacts that you need to then want to use with other aspects of OSGi, such as the resolver, right? So it's a utility plugin for Maven, and so you generate OSGi repositories from it. Like it converts the Maven dependencies and understands things like transitive dependencies and whatnot. And it's used in a number of instances during your project lifecycle. Sometimes for resolving, for instance, and also during deployment potentially. It can be used in any phase of your build lifecycle. So it's not necessarily tied to a particular one, and you need to connect it with wherever you find it to be suitable in your build lifecycle. But like it says here, it's usually associated with packaging so that you can then do a resolve operation and do things like exporting or just the validation step or whatnot. You can apply it to any project anywhere. It doesn't actually have to be a jar project that you're building. You can have you can even put it in your root of a reactor POM, let's say, or a parent POM, and say, I just want to do this work at some point during the build. I want to index up all the artifacts I built, plus the dependencies and whatnot. And it's often used, like I said, with resolving, testing, and export. And yeah, like I said, it indexes into XML format, which is the R5 OSGi R5 specified repository format, and includes all that metadata. It can index a folder full of artifacts, or the Maven dependencies. And then the indexes can also be attached to your project output artifacts so that you can publish it into, let's say, Maven Central or any other repository. And another useful aspect is that the URLs that are indexed into the XML can also be, might be apply for different scenarios, right? If you're trying to resolve locally, then you only care about having local URLs to those artifacts. But if you're publishing it into a remote repository like Nexus or Maven Central, then you'd want those to be valid URLs pointing at those remote artifacts.
So given we spent the time making some indexes, we thought probably it would be useful to be able to do something with them. So what we have now is the Bnd Resolver Maven plugin. So this is something that is enabling the use of the OSGi Resolver in your build. So that was something that you couldn't really do before. The OSGi Resolver was something that just worked at runtime and validated the deployment of your bundles in a framework. And we thought, actually, you can do cool things with it if you've got access at build time. So you can automatically calculate the list of bundles that should be deployed based on a set of input requirements. You can actually run it often directly from the command line. So if you've just made some changes and you want to check that the changes you've made are sane, then you can actually ask the resolver to resolve it. And if the answer that used to be 10 bundles is now 200 bundles, you know that maybe you've not done such a clever thing. Equally, it may be that it doesn't resolve at all, or that it gives you exactly the same answer, but you can, from the command line, do that very quickly. You sometimes also do choose to bind it into your build phases, so that in CI, you'll use the resolver to validate, but it can really just be applied to anywhere that you've got a BNDRun file, either directly from the command line or in your POM. So the important things that you need to know are that effectively it's trying to solve a requirement graph that you give it. And these requirements live in a thing called a BNDRun file, which is going to be familiar to anyone who's used BND workspaces in the past. And then the capabilities and requirements come from a repository. And there are kind of two ways of getting that repository information. So one of them is the Indexer Maven plugin that we've already heard about. So building XML indexes in one Maven phase or in the same phase immediately before this, for them then to be used in the resolver. That's quite a common pattern. But it is also possible to have an implicit repository. So an implicit repository is basically just BND saying, okay, you've not given me any other information. I'm going to look at the entire set of your POM dependencies and turn that into a repository directly for you in the build. So that's obviously something that isn't as easily able to be taken out and debugged. But in the case where you just want something that's quick and based on only your Maven metadata, it works, right?
Right, so you've built, you've indexed, and you've resolved, and now you want to go to production, let's say, and you want to take whatever that got calculated and you want to put it on another production, or you want to give it to somebody and send it to them and have just a jar file that they can just boot up. You would use the Bnd Export Maven plugin to do all those things. It's a packaging plugin, and it uses BND to generate an executable jar from the calculation that came out of the resolve and is now sitting inside your BNDRun file. So like I said, it lets users launch OSGi frameworks. So it's just a java-jar command. It usually binds it during the packaging phase, obviously, because it's a packaging operation. And it supports multiple exports, multiple executions. Because there are different exporters inside of BND, it can export into multiple different formats. For instance, the executable jar being the common one. You can also just dump everything into a run bundles directory, or a bundles directory with everything listed. There is one that generates a blueprint, no, sorry, not a blueprint, but a subsystem. I'm pretty... And yeah, and Jürgen and Mark from Data in Motion have built one to generate RCP applications from the run bundles. So this is often used, like I said, with the Indexer and the Resolver plugin. So it consumes one or more bundles. You can pass it directly a list of bundles to deploy, and it identifies the framework implementation from the metadata in the BNDRun file. And then all the bundles and frameworks that are linked in the BNDRun file are usually found from repositories, whether implicit or explicit. So that's the next one, and then indexes. Yeah, the indexes generated, like we said earlier, are from repositories. But the index files that you generate have much finer grain control, as Tim mentioned earlier.
Testing. So until this point, we've been pretty much running chronologically through. The testing plugin is actually slightly older than a couple of the ones that came before it, but you can broadly see a theme in the way that things have been created. So we needed to make bundles in the first place, and then we kind of wanted to be able to index those bundles because indexes were useful. And then we thought, okay, we should be able to do stuff with the indexes. Now this is something where actually we kind of needed the index, but we also wanted to be able to use testing before we had the indexes as well, because this is about validating that the bundles you've produced are working. So again, we do use BNDRun files to make this work, but you also have specific tester projects. And that's because the way in which BND's OSGi tests work is you actually have to build a tester bundle. So unusually, rather than your tests living in source test Java, the test will actually live in source main Java, because these things are going to be packaged up into a bundle in that Maven build, and that's your tester bundle. And that tester bundle is then going to be used with a BNDRun file to create a framework instance with bundles in it, and then those tests are going to be run. So this is usually bound to the integration test phase, and it's bound to the integration test phase because you need the packaging of your tester bundle, which happens in the package phase, to be complete. And that means if you tried to run it in the normal testing phase, which is for unit tests, that jar wouldn't have been made yet. As I've said, these are running inside an OSGi framework, which is what makes them different from unit tests. You list the tests using the test cases header, which is the same way that BND has done it for more than a decade. And you've got this BNDRun file, which is exactly the same as the ones that have been used by the Resolver and Export plugins to define the framework that's going to run your tests. So you can use the Resolver alongside the testing plugin, just like you can with the Export plugin. And obviously, this is about validating that your bundle works as an OSGi bundle. You shouldn't be using this to do unit testing, because unit tests are better, right?
So not last, but now most recently we have this BNDRun Maven plugin. And what this is for is to actually initiate the execution of a BNDRun file from the Maven command line. This enables, this is useful for development. It lets you do, it's for integration testing, testing your actual runnable and playing with it, and continuous deployment. It's useful for live coding, so you can actually activate the run. It's pointing at your live artifacts that you're editing, and as your IDE is rebuilding your artifacts, they automatically get pushed into the run. So this is not bound to any lifecycle for obvious reasons. You wouldn't want this to happen in CI and all of a sudden there's a process that starts and sits and waits, because that process that Maven starts, the Maven plugin starts, it puts the application in the foreground. So you have this, your Maven is sitting there waiting as your application is running in the foreground of the shell, so you can see, the log output and whatnot, and cancel it and use GoGo and whatever you want to do. So it's not bound in the build at any time, and it cannot be, actually. It's a plugin that can't be bound. It has to be directly invoked. But you can create a different execution of the plugin pointing at every single BNDRun file that you have in your entire project stack. So you can pick any one of your BNDRun files and invoke a run against that particular one. And it's often used with the index and resolver, obviously, because you're trying to run a completely resolved application. So it accepts and executes BNDRun files, obviously. And it pushes, like I said, the process into the foreground. And so any modifications that happen to files that are monitored by the launcher are going to cause the launcher to update the bundles that are in the running process. So for instance, if you modify your BNDRun file, the launcher is going to try to determine if that actually should have an effect on the running, and it might modify the runtime. It'll do this in a live update scenario.
Baselining. Now, I am aware that we've probably got some people in the room who were at the talk earlier today where they talked about maintaining versions correctly in your code. So this is the Maven way of getting that to happen automatically for you in your build. So it's about enforcing versioning policy. So it's normally bound to the verify phase, because you're looking to verify the artifacts that have been built against other artifacts that have previously been built. And it's effectively doing a diff of your API against the last thing that it could find in Nexus that had an earlier version. You can use it on any OSGi bundle. The place where it's most valuable is if you've got an OSGi bundle that exports API, because that's the point where it's going to be able to tell you important things about whether you've added or removed methods in a way that is going to be a breaking change for people. So, really important thing to be aware is that you do need a baseline bundle to baseline against. So by default, what it will do is it will look for a bundle that has the same group ID and artifact ID as you, and that has a version lower than yours. And it will pick the highest version thing that it can find that has a lower version than you do. And it will assume that that is the previous thing that's been released, and that it's going to need to do a diff against the API with you. Obviously, the amount of reporting detail it gives you is configurable. It can give you like a whole spiel about these are all the things I found that had changed, even if everything's okay. But the best thing it will do is if it finds that there has been a baselining error, so that say your version doesn't match what it should be, it will not only tell you what version you should change and what value you should change it to if you want to fix it that way, but it will also tell you which method changes made it make that decision, so you could actually go back and revert the API changes if you think, oh wait, I really shouldn't have broken all those customers, they're going to hate me. So very useful thing, the baseline Maven plugin, and one that people don't use as much as we feel maybe they should.
And the newest addition to the suite of BND Maven plugins is the BND Reporter Maven plugin. Now, this is a tool for generating high-level reports about your bundles. It's essentially a site-building tool that you use in your build to generate documentation for your plugin. It understands the lifecycle for BND and understands the metadata, and so you can generate you can use a templating language to generate as thorough documentation about all the details that it finds in your bundles. And this is used, like I said, whenever you need to generate documentation for your bundles. It's not bound to a lifecycle. You would invoke it specifically when you're trying to update the documentation, so maybe during a release process or whatnot. And it's used, well, anytime you're building OSGi bundles, you could use this. So important bits, like I said, it's used to generate documentation. It uses a templating system, which allows you to use a language. If I remember correctly, it's called JTwig, JTwig, to generate rich documentation. It uses a two-step process as well. So in phase one, it can just dump all the metadata into intermediate format, which is either JSON or XML. So if you prefer to use something like Jekyll to pull all that metadata in and use Jekyll to actually process and build a pre-generated site, you can actually just do that instead of using the templating system built in here. Or you can use step 2, which is actually using the template, providing templates there, and then generating output. And it can generate pretty much anything that's in text format. So, you know, markdown files, XML files, HTML files, and whatnot. And the system is pluggable. So if you find you added some extender pattern inside your bundles, and you want to be able to report how that, you know, is configured in that particular bundle, and it's not knowledge that this templating system already is aware of, you can add plugins that then work with and enhance the metadata that comes out of the bundles to have even more reporting capability. So it's a pretty powerful tool, and it's pretty new. Yeah, and it's really cool. And actually, we are still absorbing a lot of the features of this tool because it's fairly new to most of us as well. Oh yeah, yeah. This I think it took around 6 months for this person that's dedicated. Two people were fairly dedicated at this, but mostly Raymond Auge, right, who worked on this and just did a fantastic job, suffered through our strict review process, and actually got it in, and it's quite useful. It's quite cool.
So we've been talking about Maven and BND, and as I say, historically, they have not been the best of friends, and we hope that having seen all the plugins, you'll be convinced that we're putting quite a lot of effort into making this a good experience for people. And we actually did put a lot of work into BND Tools as well. So there's a whole BND Tools M2E extension for the BND Tools environment, which is about trying to make the integration with Eclipse and Maven really great. But actually, we've tried to make sure that every single plugin we produce does not care what IDE that you use. So if your IDE has any support for Maven at all, it will continue to work as it ever has. And actually, so you may not have kind of twigged with what Ray was saying about the Run plugin, but the Run plugin that we've got is giving you the same live coding experience that you get in BND Tools from any IDE that you want. You just start up the Maven Run from the CLI, and you can then just make changes in your IDE, and they will be live pushed into your running runtime. So BND Tools absolutely still has value, and we think it is the best choice for doing this stuff, because you've got things like nice editors, built-in resolve buttons in the IDE, so you're not having to drop back to the command line to do resolving, and built-in bindings for the plugins, so it knows automatically that it really does need to run the BND Maven plugin every time that it recompiles the classes, and nice error markers. So it's definitely a good experience, but you just don't need to say, oh, we've absolutely got to use BND Tools, which I know is probably a terrible thing to say at an Eclipse conference, that it's just as good using IntelliJ, but it kind of is now, which is quite cool.
So now that is quite the amount of information to digest in such a short time, right? But conveniently, we the OSGi Alliance, in particular Tim here, did a lot of work to have documentation and to have a bootstrapping model. So setting up a new Maven build can be really hard, and but there's documentation, first of all, for all of the plugins. But there's also the OSGi en route site, which provides an easy setup, and in fact also provides archetypes that let you generate projects completely populated with all these plugins ahead of time, so that you don't have to kind of swim through all the morass of the XML if you don't like to, but obviously if that's your thing, have at her. It also provides a default set of repositories that is already curated and contains a whole bunch of gold nuggets as far as the OSGi is concerned. Some very common tools, very common frameworks, implementations of the the specifications. Most of the RIs are there for all the different specifications. So it's not merely a bootstrapping of the tools, it's a full bootstrapping of all of the tool chain as well as all the dependencies that you could use to do everything from persistence to web services. And of course, it's all of these Maven plugins. So we wanted to do a little demo. How much time do we have actually? Just to make sure.
10 minutes till the end.
Okay, that sounds
People may have
about right.
questions.
Yeah. All right. So let's see how much damage I can do here. Yeah. Yeah. Go away. All right. OSGi.root. Microservice, right? Examples. Microservice. Okay, so I'm in the OSGi en route project right now. And there's a set of examples that come in the en route OSGi project. And basically, it's a multi-module project with, 7 different bundles in it. Let me see. Let's open Eclipse. Examples, launch. One thing I'm going to do really quick is forgot to delete some intermediate work. Let's just get that out of our faces. Okay, so we have a couple of different apps here. We have, first of all, this is a persistence-based example. So it's using either JDBC, we have a JDBC example and a JPA example. It's JDBC, right? And JPA. So it's a full cycle application that has persistence. It has also a REST endpoint. So we have a DAO implementation or DAO API, 2 different implementations. There is then a REST app and a REST app that uses the JPA implementation. And obviously there's a REST service. And yeah, so let's see. Let's go back here to look at the Maven build. So I don't expect you to watch what's going on here, but what I want to emphasize is that at the end of this build, what has happened is that your application started off, first of all, was built, the artifacts were built. Then it was resolved successfully, because otherwise the build would have failed. It was then also indexed before it was resolved, so all the indexes were created. And then it was tested, it was exported as an executable, and that's a very high degree of assertions against the project that you wrote. It could also have done things like find bugs and all these other things that you would normally do, JUnit testing and whatnot. But the fact that it did all of the resolving and ran the resolved product in a test environment, and that this is a very high chance of success rate, much higher than just your normal development process where you take your artifacts and you drop them in an app server or whatever, or micro container, and try to run it and go through the class not found exception lifecycle and just keep iterating, right? So the next cool thing that I want to show is really this live coding model, which is now I can, from the command line, do Bnd run, and like I said, you can target any particular execution by specifying the ID of that execution. So I'm going to go with REST service test debug, just because that gives us a little bit more tools to introspect the runtime. So I'm going to run that. Oh, I did forget one thing. One detail here. Actually, you know, I'm going to do that. I'm going to run it, but I just want to demonstrate or show one observation of why you run from the root of your reactor in a project. By running in the root of the reactor project, Maven can actually give you more accurate information about the artifacts that were built in the project. And because I didn't run in the right phase, Maven won't tell me that information. And I don't know why it's trying to download again. You know what? I can just as easily go offline mode. But so what I'm going to do here is I'm going to go package, because you want the BndRun plugin to always execute in the packaging phase, at least. And then I'm going to go offline, because we don't need to do all the downloading again. No plugin, did I do? Oh, I know what I did. This was a recent integration, so we're still ironing out a couple of bugs. Maven plugin 4.3. I wouldn't expect anyone to know this gav off the top of their head, but you would use the aliases, which are documented. So did I get it right? Let's do execute BND Maven Run plugin 4.3 run test service offline. All right. I probably used the wrong execution name. That's likely what I did wrong. REST service test, 5 minutes. I should have plenty of time to show this here. So I gotta go to the POM. Excuse me. Go down to the bottom. It was called why do I not have the executions?
You want to just show the one
here?
for the REST app?
Yeah, let's do that. We can do that. Okay, so we have multiple BND runs, right? So again, like Tim, that's a good point. We can just switch to a different, there we go. We'll go REST app debug.
You got 2 hyphens.
Oh, did I?
Yep.
Ah. Oh, and I forgot I enabled debugging on this debug file.
Yep. So yes, you can even tell it to let you attach a debugger, which is nice, because that's something that's been a nightmare to do, not in Bnd Tools, and I mean like a nightmare.
And I don't have any debug configurations, but I'll just create one really quick here. New, it's just a remote. On board 8000. Sorry, guys. Debug. Oh, I gotta pick a project. Put all of them. Ah. Okay. All right. So now our app is running, and we happen to have GoGo. So I do a LB minus S to show you that we do have a bunch of bundles there. More importantly, though, is to go to the browser and show that the application has both the console. Go away. So yeah, first we have
this is because we're running the debug version. So the debug version of the en route applications includes Felix Web Console, because it's quite helpful for debugging.
And I have a breakpoint too. All useful things except during a demo. Debug works, yeah.
As we found out about 3 hours ago when we were trying to make this work.
Okay, so now we have a REST app. A lot of things going on here. We're using HTTP Whiteboard. There's some static resources. That's the front end for our website. There's also a REST endpoint back there that's going to take the data and then send it to our persistence and then give us back the information. So it's a full lifecycle application. And I can do all the things that I need to do. The really cool thing here is that, I want to demonstrate here. I can close that, and I can go to where would be an interesting, in the service, right?
Yeah, if you put it in the REST service.
In the REST service. Come on. What'd you do? The REST service. So we have the REST component here. And I decide, for whatever reason, I want to put some activate void in it. Whatever, I'm doing sysout level debugging.
No. DS is fine with stuff that's not public.
Okay, so what I'm trying to do is show you both things.
So if you hit save.
Side by side, I guess it doesn't really matter. I was hoping to do, okay, that I can do. So if you're paying attention to the background, so that live coded my thing away, and you can see here that my foo got printed out, which means that it added so I added a method. This is like the real debugging, right? So it added a method. It's not just, updating the bytecode through the debugging API. It added a method, relaunched the bundle, or redeployed the bundle, restarted the bundle, and that's a real test of the quality of your actual code in your bundle, because you're constantly testing the initialization and destruction of all of the components or whatever framework you're using in your bundle, right? So.
And if you want to use IntelliJ, exactly the same thing will work.
Exactly. And that's it.
Okay. Thank you, everyone.
We're more or less completely out of time, but do we have one final question? Anybody? Before it's time for...
Yes. Yes. Yeah.
It's exactly the same support that BND has. You've got access to all of BND.
Yeah. Just.
So you can't create update sites using this because BND doesn't know how to create update sites, but Tycho has plugins for that.
Yeah, but we cannot mix up. Because Tycho is working on many test files.
But you could do that in another module in your reactor build, right? In one module, you could have specifically dedicated to creating P2 repositories. And then all of your other modules can say, I don't care about Tycho at all.
Okay, that would be useful.
And in terms of consuming from P2, you can use the configuration to set up a repository that will consume from P2 to do BND run resolves and stuff.
Yeah.
So that's the level.
You should put it in your BND run file, don't you?
Yeah, you have to configure it into
Yeah.
the BND run file.
Yeah, anytime, that's a good point, just to clarify. Anytime you're using a repository that is not either either standalone, part of BND's standalone support, which is only the OSGi indexed repository type. Any other time, you have to specify the repositories in your BND run files. Yeah, or Maven, or the Maven dependencies themselves. Yeah. For,
So that would be the implicit repository we were talking about earlier.
Yeah.
So if you have things that you're depending on in your Maven dependencies section, and you don't put any kind of index in there at all, you still have access to those things from your Maven dependencies.
But you couldn't declare the P2 repository as a repository, right?
So Maven doesn't understand P2, so
Yeah, that's where the Tycho part.
But our plugins aren't involved in that part. Maven tells our plugins what the dependencies are.
Yeah.
And we can use that information. We can't go and say, oh yeah, so we need to dig around and work out what artifact repositories you have. And
Yeah.
yeah. It's not the Maven way.
Okay, thank you everybody for today. This was the last session